Question 7. Figure 7 represents a capillary surrounded by tissue fluid. The values of the hydrostatic pressure are shown. So 7.1, use the information to explain how the tissue fluid is formed. So we can see that at the arterial end, the hydrostatic pressure is higher inside of the capillary than the hydrostatic pressure outside, 4.3 on the inside, and on the outside it is 1.1. And we can see that as it goes through the capillary, then at the venal end, the hydrostatic pressure has decreased. So using this information, we can say that the hydrostatic pressure inside of the capillary is higher than the hydrostatic pressure on the outside. Therefore, there is an outward pressure of 3.2 kilopascals. So we've done 4.3 minus 1.1 and worked out the difference, and that is an outward pressure, which is the overall force, and this will force the small molecules out of the capillary, which will then make the tissue fluid. So some people in this question like to talk about osmotic pull, but because this asks us to use the figure 7 to explain how the tissue fluid is formed, it's only telling us about the hydrostatic pressure. So that's the only thing we need to comment about in this answer. 7.2, the hydrostatic pressure falls from the arterial end of the capillary to the venal end. Explain why. And this is due to the loss of water or the loss of fluid, or the fact that there is a reduced friction against the capillary lining. So as the blood goes through from the arterial end into the venal end, because the hydrostatic pressure is much higher on the outside than on the inside of the capillary compared to the outside of the capillary, the blood will go down, the tissue fluid will go down the pressure gradient, so it will go from inside of the capillary to the outside, which then means that some of the fluid or the water or the tissue fluid will be lost, so you end up with a smaller amount of fluid inside of that capillary. Therefore, that's going to reduce the hydrostatic pressure.